light is going to hit all the opposite wall. Okay, and as you move inside, now it will become something like this. So your area is, it will expand for a while using the formula that you have found, but after a while, that area is going to become constant. Okay? So you may want to consider that type of a situation. Okay, so you can say, it will be this up to this time, and after that time, it will be something else. The function may change after a while. So it's essentially, using your knowledge and some mathematics actually. I'm not going to go into details and solve it. It will take a while.
Sir, can you repeat part A?
Part A, solid angle. Solid angle is this area divided by this distance squared. Okay. Now, if my, since this direction is orthogonal to this plane, okay, cosine theta is cosine 0, which is 1. Cosine 0 is 1. Okay. But it could have been something like this. I'm not sure, but it could have been maybe with an angle. Okay, I'm expanding it. So in that case, this is the direction, this is the surface normal. Then there will be some angle, for example. So you need to take care of that. Okay.
Bu örnek için hocam b plus n'in square'i.
Yes, it will, in the denominator there will be b plus a squared and so on. So from there actually it will be inversely proportional with t squared. So you can, based on that, you can do the math and solve it. Now, one exercise is a hint for the final exam. Try to do this. Let's say we have a sphere, maybe an earth. Okay? So we have our earth and we have the sun. Okay, which is a point source at infinity. Okay? And from that we are measuring the, we can measure how much light comes in. Okay? Maybe from there we can extract some additional information. Okay? So for preparation for the final exam, study the geometry of, for example, a sphere with a light source at infinity, how the intensities are going to change. Let's say you have a satellite somewhere, you're taking a picture of the Earth. Okay? What will be the function of the intensity on the Earth's surface, assuming a perfectly, spherical structure? What you will measure, for example. Okay? So writing, solid angles, writing the total power received, irradiance, and so on. Do some math maybe on the on such a spherical surface, and also you can do some exercise on photometric stereo as well. So if the position of the Earth changes with respect to sun, okay, what's going to happen? Okay, so I measured maybe in September an intensity somewhere. I measured it in, let's say, February and in some other time. So I give you the directions. So in such cases, from that, can you find the surface normal? Okay, something like that. I'm just making it up right now. Yeah, putting everything together, astronomy, computer vision, physics, all put together. This I'm not going to ask it in the exam because we already covered that part and asked in the midterm exam. And the final one is Write the homographic matrix for the following cases. The image is translated by x2, y4. Do you remember the homographic matrix? A little bit?
Yeah.
Okay. So we have, for example, a point x, y, 1 multiplied with the homographic matrix capital H, and we're going to have x prime, y prime, and 1, and there will be a scale factor lambda in front. Okay. So that is the homographic transformation. So the first one is we do a translation by 2 in x direction, y in 4 direction. So from this 1, 1, 1, 0, 2, 4, 0, 0, 0. What will this do? From the last row, lambda is equal to 1. Okay. First row, once lambda is equal to 1, x prime is equal to x plus 2. Y prime is equal to y plus 4. So that will do a translation by 2 in x and 4 in y direction. The image is scaled by a factor of 2 in both x and y directions. Okay, that part B. The image is rotated by 30 degrees in counterclockwise. Cosine theta minus sine theta, sine theta. Okay, the rotation formula was something like this, but you have to make sure this rotation is doing clockwise or counterclockwise rotation. You have to verify that, because if it is clockwise rotation, then this will be plus and minus. So you counterclockwise and clockwise rotation, the only thing changing is this sign over here. You're going to make it either minus 1 plus 1 or plus 1 minus 1, depending on counterclockwise or clockwise. So you need to figure it out. And for the theta, you're going to put 30 degrees. The image is first translated by 2 and 3, and then rotated by 15 degrees clockwise. So first, you will do a translation 1, 1, 1, 0, 0, 2 and 3, 0, 0, 0, and then you will do a rotation cosine theta, cos theta 1, 0, 0, minus sine theta, sine theta. Again, you need to make sure all this sign over there. You put the theta in there, which will be equal to, x prime, y prime 1 and lambda. And you can multiply these two matrices, x, y, 1, to get a single homographic matrix, which is going to be 3 by 3. Okay. So that is your solution. If you leave this in this way, it's fine, perfectly fine. You don't need to do all the, matrix product and get a single matrix in there. This is enough for me to see that you understood what to do.
Bu homographic matrix'in yani neye göre değiştiriyoruz yani sayıları veriyorsunuz ama nasıl anlamadım orası yani.
Okay, we need to study that. Okay, translation. Translation on. For example, it says translate by x2, y4. So x prime is x plus 2, y prime is y plus 4. This is what we would like to have. But of course, we don't want to write it in this way because we may have a combinations of those transformations. So what we do is we utilize this homography matrix, which is a 3 by 3 matrix. We can put all our transformations back to back and generate an overall transformation. Now, in the homework assignment that I gave to you, you're going to find the homography matrix. You're going to stitch the images. You will, as a bonus part, I said, stitch more than 2 images.